Hi folks! Today we're looking at notation for the slope function and also sort of a more common way of finding slope. If we look at this last question from the last video, it's super tedious. We had to go through this process 3 separate times to find 3 separate slopes on the same function. I only have one of them written here because, of course, doing all 3 of them would have taken more than one slide. The full solution's at the end of the last video, but it was very tedious. So here's our setup. Notice that finding the tangent slope of a curve at multiple points is extremely tedious. So instead of applying this limit of f of a plus h minus f of a all over h several times, we could just find sort of a function or a formula that gives the tangent slope at any x value. The type of slope function, or this type of slope function, is called a derivative, and we write it like this. F kind of looks like an apostrophe, f prime of x. The process of finding the slope function, again, that's the derivative, that's what it's called, is called differentiation. So the verb is differentiation, the noun is the derivative. Okay? In French, they're both dérivés. To find the slope function, simply replace a with x in the limit expression earlier. So if we want this derivative function, here's the only thing that changes. We go lim as h goes to 0. Instead of at a specific point, it's at some general point, x. So it'll be f of x plus h minus f of x all over h. We just replace a with x here. This is the slope of f anywhere. And then we can sub in values at the end. Okay, and it just comes from applying that limit. And if you were to get a calculus tattoo, I mean, this is probably the one, though I don't recommend it at all. This is super important. This is called first principles, and it's the way that we can find the derivative function from elementary methods. It's a more common approach for finding tangent slopes. Alternative notation for the derivative. So you might see this, f prime or y prime. Okay, that's nice and quick and easy. You also might see it written this way, dy over dx. Now think about that. That's like delta y over delta x, or difference in y over difference in x. That reinforces the idea that this is a slope, and it also tells you what the slope is related to. It's the change in y over x. So that if we have weirder variables, like say time, you would know what the units are. Okay. We also might see df over dx. So this is clearer. It's called the Leibniz notation. And this is another thing we might see. D by dx of y, or d by dx, d over dx of f of x. Okay. In this case, what it's trying to get across is that this is the verb, differentiate. It's telling you differentiate whatever y is, or find the slope function. All of these notations mean the exact same thing. They all mean this slope function, f prime of x. So let's see how that works in the exact same example that we left off for the last video. Same question, hopefully a more concise approach though. So the slope anywhere is given by this expression, f of x plus h minus f of x all over h. Now f of x we actually already know. That's really easy. What we need to go off to the side and find is what f of x plus h is. Okay. So I'm going to do that over here, and it's going to be kind of annoying. Remember, if we see f of 1, we put 1 in for x. If we see f of 2, we put 2 in for x. If we see f of x plus h, we put x plus h in for x, and just see what we get. And this is going to look a little bit more messy than when we had a number, but the payoff at the end will be worth it. Let's square this. So if you're thinking about x plus h all squared, that's x plus h times x plus h, which would give us x squared plus 2xh plus h squared. And then we'd have plus 2x plus 2h minus 5, or negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h minus 5. And that's kind of a messy expression, but it's just what we need to sub in. Notice that there are no like terms to collect, so we can now start to sub this in. So it's going to be lim as h goes to 0 of that whole mess, the f of x plus h. So that's negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h minus 5. Okay. And then we have to subtract off f of x, which is easier. It's this thing here. I'll put it in green. Minus negative 3x squared plus 2x minus 5. I'm going to put a little line down here to show that these are kind of separate pieces. Okay, and this is all over h. And I'll go through the process here of showing each little bit, but you might already see things that cancel out. So if I do this by expanding that bracket, we can see that there are some terms that cancel out. Negative 3x squared and positive 3x squared, you might have seen them here. If they're the same but they're being subtracted, then they'll be gone. 2x and negative 2x, they're gone, and negative 5 and positive 5. So things are starting to clean up a little bit. Lim as h goes to 0 of negative 6xh minus 3h squared plus 2h all over h. And now we have to factor so that we can get rid of our problem h on the bottom. So there's a common factor of h. You could also have taken out negative h, but I think this is probably just as good. Okay, and now we can cross out those h's. They divide out. So we end up with f prime is lim as h goes to 0 of negative 6x minus 3h plus 2. And at this point, we can actually sub in. F prime is going to be, as h goes to 0, negative 6x will just be negative 6x. As h goes to 0, this will be negative 3 times 0 plus 2. Or we can simplify that, and you could just write it right away as negative 6x plus 2. That's the slope anywhere. And yeah, it seemed tedious, but the only real tedious part was finding f of x plus h and actually plugging it into this limit formula. The nice thing that happens now that we know this, so I'm just going to write it over here again. F of x is negative 6x plus 2. Now, if I want the slope at negative 3, all I do is sub negative 3 into this. So f prime at negative 3. That reads the slope, or tangent slope, at negative 3 is going to be negative 6. I put in negative 3 for x, and that'll give me 20. Next, we'll find the slope at x equals 2, and that's easy. We just sub in 2 into the slope formula. So f prime at 2 means slope at 2, or tangent slope at 2. So I just plug it into this f prime formula right here. Okay, so slope at 2 is going to turn out to be negative 10. And the actual process of finding the slope goes really quickly. If I want to find the slope at 1, I put in 1 to the slope formula. Bam. That gives us those answers more quickly because we have a formula for the function anywhere. And that derivative function has a look too. So the original one looked like a quadratic, the f, and the f prime looks like a linear. The rest of this video is just going to hinge around examples for doing these. So if you feel like you've got a grasp on it, I'll go to the practice questions and then come back for some examples. Here's the practice, and the answers would be 1, 0, 3x squared, 4x cubed, 2, 2x minus 3, and 3x squared minus 4x. But chances are we actually need a little bit of practice here. So we're going to find dy by dx, in other words, the slope function, or the derivative is its real name. It can be written as dy by dx. You could also write it as f prime of x if you change this to an f of x notation, which might be nice, or y prime. All those things mean the slope. If you see a prime or a dy, think slope. All right, so we've got f of x already. Let's remember the formula. This is first principles. And you might be asked to find a derivative from first principles on your final exam. It'll probably be a polynomial if so. Okay, that's great. We already know f of x. What we need to go off to the side and find is f of x plus h, just so we can sub it in, okay, right here. So f of x plus h just means replacing x with x plus h. And we'll get a little bit of a mess because we're adding in a variable here. But there's f of x plus h. I did that work off to the side so that now when I can plug it in, it'll be easier. Okay, so f of x plus h is what we have to sub in first. It's this thing, so 2x plus 2h minus 3 minus f of x. F of x was the function that was given to us. Make sure you put it in brackets. You're subtracting it all off. Okay, now let's see if there are any terms that are going to subtract off. 2x and the 2x here are going to go. Negative 3 and this negative 3, because you're subtracting negative 3, you're adding 3, they're going to go to 0. So f prime will be the lim, as h goes to 0, of 2h over h. Or f prime is the lim as h goes to 0 of these divide out of 2. And as h goes to 0, 2 is just 2. Now let's see, does that make sense that the slope on this function everywhere would be 2? Yeah, the original one's a line, so of course its slope everywhere is 2, no matter what the x value. This is probably the worst way of showing that the slope of a line is 2, but it's nice to know that our techniques are consistent, that they give the same result. We'll do another. Again, f of x is equal to this. We'll use that kind of notation, and I'll write down first principles. Off to the side, I'll figure out what f of x plus h is, and it'll be more complicated in this one, because this one's going to have slope that is in flux, because it's a parabola. So for x, we sub in x plus h, all squared, plus 4. Again, any x's that we see, we're going to replace them with x plus h. So x plus h all squared. You could do this from Pascal's triangle if you want. It's going to be x squared plus 2xh plus 1h squared plus 4x plus 4h. Or you could do it just by foiling it out, or you could have some other trick. Just memorize the formula. And now we plug and chug. There's my f of x plus h minus all of my f of x. Okay, there are a lot of terms here, but some of them divide, or some of them add out, or they add to 0. X squared and this x squared that we're subtracting off, that's going to go. And 4x and this 4x, they're going to add to 0. If you're not sure, you can show the step of actually getting rid of those brackets. But with a polynomial, we'll have this property. So we get 2xh plus h squared plus 4h. And then we're going to factor out so that we can get rid of our problem h on the bottom. So h by 2x plus h plus 4 all over h. And these h's divide out. That gives us lim as h goes to 0. So notice in every step so far I've written the limit. The limit is still there until we substitute in. At the very end, When I substitute in 0 for h, I'm going to get 2x plus 0, which I don't really need to show, plus 4. So the slope anywhere on this parabola can be found with this handy little formula of 2x plus 4. Later in the chapter, we'll look at the relationship between the original function and the look of its graph of its derivative. But for now, we're just finding this formula for slope at any point. We've got 2 more examples, but if you're feeling confident and you just want to go to the practice work, that's fine too. So I'm going to think of this as f of x. I'm going to need to find f of x plus h. I know that over here. So that would be 2 times x plus h all cubed. Now, you can square it and then times it by x plus h again, but I think it would be nice here to just think about Pascal's triangle if we've got higher powers. So the coefficients of this expansion are going to be 1, 3, 3, and 1. And we're going to start with highest power on the first term, x cubed, then x squared, then a regular x, then x will disappear. The second term, the h, makes its appearance in the second term, and then its powers get bigger. Okay. So maybe you didn't want to see those 1s there, so you didn't have to write them. 2x cubed, when we multiply it out, because I'm just going to distribute now, there's no like terms to collect. 6x squared h plus 6xh squared plus 2h cubed. All right, there is our f of x plus h. And there's first principles, and we'll just sub in. So lim as h goes to 0 of f of x plus h, that's the stuff I found in red. So that's 2x squared plus 6x squared h plus 6xh squared plus 2h cubed minus f of x. I don't really need the brackets here, but I'm going to put them in just to be careful. And you can see that x squareds, they're going to subtract out. What does that leave us with? Still a bit of a mess. Not too bad. And we get 6x squared h plus 6xh squared plus 2h cubed all over h. You could factor out a 2, but I don't think there's any point. Let's just factor out the h because we want to get rid of it. So that will be 6x squared plus 6xh plus 2h squared all over h. And finally, our problem can go. We're almost there. We've got 6x squared plus 6xh plus 2h squared. And when I put in 0, the first term is just going to become 6x squared. The next term is going to be 6x times 0. And the other one's going to be 2 times 0 squared. The only one that sticks around is the 6x squared, which might lead you to look for some patterns. Okay, one last one. This is our f of x. F of x plus h here. I'll do it in red like I have before. F of x plus h, there's no x involved in the function at all. So that means that if I put in -3, or if I put in x plus h into -3 for x, nothing will change. There are no x's at all. So f of x plus h is also -3, because on this function, the y value is always -3. All right, let's go through and find the derivative function. Lim as h goes to 0. I'm going to write the whole thing out. F of x plus h minus f of x all over h. And in this case, that will be -3, the f of x plus h, minus f of x, which is -3. And that gives us 0 over h. And that makes us say, oh no. Because we know that we can't divide 0 by 0. But here's another little sleight of hand of limits. It's not saying that h is 0. h is just really close to 0. So 0 divided by something really close to 0 is going to be 0. 0 divided by anything other than exactly 0 is defined as 0. So this slope, this limit's still going to work out, even though we can't substitute directly. We get f prime is 0. Does that make sense? Let's think about the original function. The original function was a horizontal line at -3. Is its slope always 0? Heck yes. So again, here's the practice. You're going to use first principles to find some of these derivatives. I'd say give yourself a 10-minute timer, see how many you can get done in 10 minutes, and then sort of tap out from there. To recap, the key skills we found so far are to find a simple limit, to find the equations of asymptotes, to find the slope of a tangent at a point on the curve, so the f prime of a, or now you could find the slope function and sub in, and find its derivative function. That's the new thing today. Much of what we've done so far will be explored with more efficient approaches soon. However, this material forms the groundwork for all differential calculus, and you're likely to see it again in your first year calc class. And also, finding a derivative from first principles is fair game for the IB exam, at least for simple functions like polynomials. Once again, here's the practice and the answers. I hope this has been helpful. Good luck with the material, folks, and take care.